Okay, question number two. Question number two is a skateboarder and drops through a vertical height which have a dip of a radius of curvature of 60 meter. Okay, so now this system you will see it very oftenly on the X game where the skateboarder going to the half pipe, we call that, maybe in another technical terms by the X gamers. Okay, is a half pipe. Now, question number 8. Assuming no energy loss due to friction and frictional resistance, so it means this is your ideal system to calculate the speed of a skateboarder at the bottom of B. Okay, now you can see where is B, is it? Okay, it's about 5.2 meters from A. Okay, now and you may assume that the speed of the skateboarder at point A is 0. Okay, now question B. Calculate the centripetal acceleration of the skateboarder at point B and finally calculate the contact force R acting on the skateboarder at point B. Okay, so let's go see. Now let me call out my pen first again. Okay, so now part A. Part A want you to find the velocity. So I draw the half pipe or the dip. Okay, now this is B. So there is a skateboarder at this part, the bit bed, and this is part A. Now there is a difference in height of 5.2 meter. Okay. Now bear in mind that in physics we are not only doing a simple, applying a one simple concept. So you have to remember that physics is very wide, okay, aerial. So where you need to apply different concept, different ideas in the system. Okay. So in this system, we learn about motion in circle, but we are not using motion in circle to solve the system. We are using the conversations of energy to solve this question. Okay. Now, in at A, the skateboarder will have a potentials. Okay, potential energy. So what is the potential energy? Okay, so the potential energy will be mgh. Now, all the potential energy will convert to kinetic energy, okay, at B. Okay, so here we go. We will get our velocity here. Take away the m, so my velocity will be equal to square root of 2gh. So plug in all the parameters that are given to you, you will eventually come to the answer as 10.1 meter per second. Looks very simple, right? Okay, should we not have any problem until this part. So now question B, part 1 is want you to find what is the centripetal acceleration at point B. Again, it's very simple. A equal to v squared over r. Since now you have the velocity that you found in part A. So again, 10.1 square divided by, now be careful, the radius is not 5.2 meter. Check back the question. The radius is actually somewhere that we written here is 16 meter. Okay, 16 meter. Okay, so it will be divided by 16. So finally you will reach the answer as 6.38 meter per second. Look very simple, no problem at all, right? Okay, question number 2. Okay, so let me draw again the system here. Okay, so now the skateboarder is reaching at point B. Okay, at point B here. Okay, so hooray, it's reaching at point B here. So the first thing you have to do is you have to find out what is the forces act on this system. Okay, so you have to remember, bear in mind that there will be a reaction force here, and there will be a great gravitational force at this part. Now, the difference between these two forces will provide to our centripetal force. Remember that centripetal force will not come as a free. Okay, there is some other force that provide to it so that it will change the directions of the speed, become velocity. Okay, so here very obviously we know that r minus mg. Okay, R minus mg. If because R must be larger than mg, so that it will stay on the curvature dip. Okay, if mg is larger than R, means that this skateboard will go down towards to the other side, but it's impossible. So in this system, we know that R must be larger than mg. So again, R will be equal to Fc plus mg. Okay, so Fc will be ma plus mg, where m, now my a is given, we found it in V1 6.38 plus, now the g is 9.81. Okay, so it will be, by putting all the parameters where m is equal to 70 kg, you will get the answer as 1133 Newton. That's it. So it's very simple. Okay, for the question number